Now that we know how to calculate determinants, we want to look at some of the other things that we can do with them. One of which is to use what's called Cramer's rule, which relies on the determinant in order to solve linear systems. The easiest way to explain this is just to look at an example. So let's say that we've been given this linear system of two equations and two unknowns, so 9x plus 10y equals 34, and negative 6x minus 5y is negative 26. Cramer's rule gives us simple formulas for the values of x and y that make this system true. So the formula for x is just what we call the determinant with respect to x divided by the determinant of the coefficients. And then the formula for y is similarly the determinant with respect to y divided by this coefficient determinant, which means that in order to find the values of x and y, we need these values here, dx, dy, and d. So in order to solve these problems with Cramer's rule, the first thing you want to do is make a coefficient matrix from your system. So you just take the coefficients on your variable terms. So in our case here, that coefficient matrix is this 9, negative 6, the coefficients on x, and then 10, negative 5, the coefficients on y. So we start there, and then we also want the answer column matrix, this 34, negative 26. So we have here 34 and negative 26. We kind of want to establish these two things on their own. Now remember we said here that this column represents the coefficients on x, and this one represents the coefficients on y. So when we want to find the determinant with respect to x here, we take the answer column matrix and we substitute that in for the column that represents x. In other words, the determinant for x is going to be equal to, we would take this 4x4 determinant, but instead of the x column, we'll use the answer column matrix. So we'll say 34, negative 26 in place of x, since we're calculating the determinant with respect to x, and then 10, negative 5. If we find this value here, we get 34 times a negative 5 is a negative 170, minus 10 times a negative 26 is a negative 260. So we have negative 170 plus 260, or 260 minus 170. That's going to give us 90. Then to find the determinant with respect to y, again, we start with our coefficient matrix, 9, 10, negative 6, negative 5. But in place of the y column, we use the answer column matrix. So this time, the 9 and the negative 6 stay, but the 10 and the negative 5 get replaced with 34, negative 26. And when we calculate this one, we get 9 times a negative 26. That's a negative 234, and then minus 34 times a negative 6. That's a negative 204, so negative 204. We get negative 234 plus 204, or 204 minus 234, and that'll just be negative 30. And then finally, we take the determinant of the coefficient matrix itself. So that's 9, 10, negative 6, and negative 5. And that determinant will be 9 times a negative 5 is a negative 45, minus 10 times a negative 6 is a negative 60. That's going to give us negative 45 plus 60, or a positive 15. So then to calculate the solutions for x and y that make this system true, we simply take x is equal to, the determinant with respect to x was 90, so we get 90, divided by just the determinant of the coefficient matrix, which we said was 15. That's going to be 6. And then for y, we take this negative 30 divided by 15, so negative 30 divided by 15, and we get a negative 2. So the solution to the system here is xy equals 6, negative 2. And then we can also do this for systems of 3 equations in 3 unknowns. It's the exact same process, except we're going to have 3 by 3 determinants. So for this one, let's go ahead and get our coefficient matrix. We have 3, negative 2, 1, negative 2, 1, and 5, and then 7, negative 5, and negative 4. And then our answer column solution will be the negative 41, 26, 57. So let's find first the determinant of this coefficient matrix. So that's going to be D, and let's just work along the first row here. So we'll get 3 times 1, -5, 5, and -4. And then we'll have the -2, so -2. And then -2, -5, 1, -4, so -2, -5, 1, -4. And then the 7, so 7, and we'll have -2, 1, 1, 5. And then coming back to our signs, as always from our checkerboard pattern, working across the top row, we have a positive, negative, positive. So positive, and then negative, and then positive. So here we'll get 3 times, we'll get a -4, 1 times -4, minus a -25 or plus 25, minus a -2 is a +2, and then we'll get -2 times a -4 is a +8, -5 times 1 is a -5, so minus -5 is +5, and then we'll get +7 times a -10 minus 1. And the result there is going to be 3 times 21 plus 2 times 13 plus 7 times -11, or 63 plus 26 minus 77, and that's going to give us 12. So we'll go ahead up here and start collecting values. We'll say D is 12, and then we can go ahead and get rid of the rest of this here so that we have room for our other determinants. To get the determinant for x, we'll replace this first column, the coefficients on x, with our answer column matrix. So this is going to be here, -41, 26, 57, and then the other two columns. So -2, 7, 1, -5, 5, and -4. And then if we work along the first row here, we'll get a -41, and then 1, -5, 5, -4. We'll go to the -2, so -2, and then we'll get 26, -5, 57, and -4. And then the last one will be the 7, so 7 times 26, 1, 57, and 5. And then we need our checkerboard pattern signs. Since we're working along the first row, we have positive, negative, positive. So positive, negative, and positive. So the result here is -41 times, we have a -4, and then minus a -25 or plus 25. Here we have a +2, and then 26 times a -4 is a -104. We've got minus a -285 or plus 285. And then we have +7 times 26 times 5 is 130, and then minus 57. So the result, if we put it up here, we get -41 times -4 plus 25 is 21. We get +2. 285 minus 104 is a 181, so times 181. And then 130 minus 57 is a 73, so we get +7 times 73. -41 times 21 is a -861. 2 times a 181 is 362. And then 7 times 73 is a 511. 362 plus a 511 minus an 861 is just a +12. So for the determinant with respect to x, we get dx equals 12. And then we can go ahead again and get rid of this, so we can do y and z. So we'll take away all of this. And then for y here, we'll get d sub y is, this time we'll replace the second column with the answer column matrix, since the second column represents the coefficients on y. So we'll get the determinant here, 3, -2, 1. And then this time, -41, 26, 57. And then leave the third column, 7, -5, -4. So the result here, let's again just work along the first row. So we'll get 3 times 26, negative 5, 57, and negative 4. And then we'll get the negative 41 times negative 2, negative 5, 1, negative 4. And then the last one will be 7, and that'll be negative 2, 26, 1, and 57. And then across the first row, our checkerboard pattern is plus, minus, and then plus. So when we simplify this, we'll get 3 times 26 times a negative 4 is a negative 104. Negative 5 times 57 is a negative 285. So we have minus negative 285 or plus 285. We have minus a negative 41, so that's plus 41. Negative 2 times a negative 4 is a positive 8. Negative 5 times 1 is a negative 5, so we have minus a negative 5 or plus 5. And then we have plus 7 times negative 2 and 57 is a negative 114, and then minus 26. So if we go up here, negative 104 and 285 is 181, so 3 times 181. 8 plus 5 is 13, so 41 times 13. And then negative 114 and negative 26 is a negative 140, so plus 7 times negative 140. And we get here 3 times 181 is 543. 41 times 13 is a 533. And 7 times a negative 140 is a negative 980. So 543 plus a 533 minus 980 is a positive 96. So we can say up here the determinant on y is a 96. And then we'll go ahead and get rid of this, and we'll look at the determinant on z. So the determinant for z will be d sub z is equal to, we'll substitute this time the third column, the coefficients on z, for the answer column matrix. So we'll get 3, negative 2, negative 2, 1, 1, and 5, and then we'll pull in our answer column, negative 41, 26, 57. And so then here, we'll break this into 2 by 2 determinants. Again, let's just go along the top row to keep it easy. So 3 times 126, 557. And then we have the negative 2, so negative 2. And then here is going to be negative 2, 26, 1, and 57. And then we have the negative 41, so negative 41. And that'll be negative 2, 1, 1, and 5. We need to add in our signs. Since we're going across the top row, we have plus, minus, plus. So plus, minus, and then plus, like this. And then when we simplify, we'll get 3 times 1 times 57 is 57. 26 times 5 is 130, so minus 130. Then minus a negative 2 is a plus 2. Negative 2 and 57 is a negative 114 minus 26. And then plus a negative 41 minus 41 times negative 10 minus 1. So if we go up here to simplify, we get 3 times 57 minus 130 is a negative 73, so negative 73, plus 2 times negative 114 minus 26, that's a negative 140, and then minus 41 times negative 10 minus 1, negative 11. And then 3 times negative 73, that's going to be a negative 219. 2 and a negative 140 is a minus 280. And then negative 41 and negative 11, I'm going to have positive 451. 451 minus 219 minus 280 is going to give us a negative 48. So I can say the determinant on z is a negative 48. Now we'll just get rid of everything that we have here, and all we have to do is calculate our values for x, y, and z. So Cramer's rule is going to tell us that x is going to be given by dx over d, or in this case, 12 over 12, so 12 over 12 or 1. The value of y is going to be dy over d, or 96 over 12, which will be 8. And then z is given by dz over d, which is negative 48 over 12, so negative 48 over 12, or negative 4. So then the solution to the linear system of 3 equations will be x, y, z is equal to 1, 8, negative 4, which we found using Cramer's rule.